Swayam Prabha. Digital India. Educated India.
Welcome everybody. Welcome to the course of reactive intermediates, carbenes and nitranes. So far we are learning the reactions of carbene. We have started the first type of the reactions in carbene, that is called addition reactions. Today we are still continuing that addition reaction on, that means the addition of the carbene moiety to various unsaturated bonds, mostly these double bonds and triple bonds. Today we will see that how these carbenes will react with various type of double bonds, including the double bonds that is inside the heterocycles. Let us start with the heterocycles first. As per example, if we have this pyrrole moiety, this is one 5-membered nitrogen containing aromatic heterocycles. Now, if we treat this one with this CCl2 carbene, then first it will form one cyclopropane ring containing 5-membered derivative, that is this bicyclic compound. Okay. Once this has formed, then the ring will open and eventually the expansion of this 5-member ring to the 6-member ring will happen to provide another 6-member nitrogen containing heterocycle, that is called the pyridine derivative. Okay. So, here from nitrogen containing 5-member ring to another nitrogen containing 6-member ring can be formed by just additions of the carbene moiety. Similarly, another heterocycle, that is called indole, that also can react with the carbene moiety to provide its ring expanded heterocyclic moiety, that is called quinoline moiety. So, here we have taken the 3 positions methyl substituted indole moiety. Now, if we take this methyl lithium as base and the carbene precursor as dichloromethane. Okay. So, now if we treat it under these conditions, then what will happen? Then actually it will form, as per the expectation, this fused ring system where it have this cyclopropane ring, and once this will form, the ring expansion will happen through this way, okay, to provide the quinoline moiety. Okay. So, starting from indole moiety, we are getting another very important nitrogen containing heterocycle, that is called quinoline moiety. Interestingly, if these particular substrates treated with another carbene, alene type of carbene, that is this one, okay. This can be generated from the 3-chloro-3-methyl 1-butene. From there we can generate this in presence of base. This will give this type of alene type of carbenes, and once we will treat this alene type of carbene with the 3 substituted indole, then immediately this will form like previous way. Okay. So, it will also form okay. And once it will generate, then similar way this ring expansion will happen, okay, and this will pick up the proton from the reaction medium, and overall this will again provide the ring expanded this quinoline moiety, and it will give this type of quinoline derivative having one vinyl group with its. Okay. Here in the previous case, when we have used this dichloromethane in presence of methyl lithium, actually it will generate the carbene, that is that CHCl dot carbene. So, here it will be CHCl. So, overall this will give this 4 methyl substituted quinoline, whereas here this in presence of this alene type of carbene, this will give the vinyl and methyl substituted quinoline. Okay. So, starting from one heterocycles, we are getting another class of heterocycle just by using the carbene as a reactive intermediate. Okay. Next, what we will see that what will happen if we use different type of naphthalene, methoxynaphthalene type of compound. That means, what I am saying here, that if we take that beta methoxynaphthalene and alpha methoxynaphthalene in presence of the carbene, dichlorocarbene, what will happen? So, let us take this. So, this is the beta methoxynaphthalene. Now, if we treat this with dichlorocarbene, okay. So, what it will form? This will react with this double bond. Okay. So, this is obvious because this is having this lone pair. So, obviously, this becomes this place become reactive mode, and once it will generate the cyclopropane ring. Okay. So, this will form the corresponding cyclopropane, okay. And once this will form, this OMe group, oxygen is having its lone pair. Now, this ring can expand, okay. So, once it will expand, then actually we will get that halobenzotropone type of derivative. That means, starting from 6 member ring, here we are going to 7 member ring. So, the end product will be okay. These are nothing but halobenzotropone type of derivative. So, we have started 6 that means naphthalene ring, and we ended up with 6 okay. So, this is nothing but benzotropone type of derivative. Fine. Now, what will happen if we use the alpha methoxy naphthalene. That means, it is another isomer, that is nothing but this alpha methoxy naphthalene. Now, if we treat this with dichlorocarbene, it will form the corresponding cyclopropane ring, okay. And once it will form, again in similar way the this will okay. So, the ring will open, and what it will form, that the corresponding ring opening product, that will give okay. So, what it will form overall, this product will be this benzotropone type of moiety, okay. So, in this both these cases we got the expansion of the ring by the simple reactions with the carbene with some aromatic ring. Okay. Next, we will see that same carbene reaction with enamine type of systems. What will happen if the dichlorocarbene will react with the enamine system? Let us take that, let us say with the enamine system. I hope that you know how to prepare different type of enamines. So, we will directly take this enamine as per example here. Okay. We have taken this enamine and treated this with dichlorocarbene. So, what we know, that this double bond now will react nicely with the dichlorocarbene to provide the cyclopropane containing derivative first or the intermediate first. Okay. So, that will give you this cyclopropane ring. Okay. So, now this nitrogen containing its lone pair. So, now that will come and the ring will expand, okay, by this liberation of Cl minus. So, that what you will get? You will get the ring expansion, okay. Now, after this the hydrolysis will give you the cyclohexenone type of derivative. Okay. So, you have started with the 5 member ring, now you obtained this 6 member cyclohexenone derivative just by using dichlorocarbene. So, that also again this dichlorocarbene is making first cyclopropane ring, after that ring expansion that gives the enamine system to the corresponding cyclohexenone system. Okay. So, so far what we have learned, in that case these dichlorocarbenes are actually first forming this cyclopropane and then it is converting to its higher ring number containing the derivative. Now, what we will see, that if any substrates that is already in a bigger ring than 6 member, in this case if we take the cycloheptatriene as the starting material, what will happen? We will see that. Let us see, first we will take the cycloheptatriene as the starting material. Okay. So, let us see how many rings, sorry. So, this is the cycloheptatriene. Okay. Now, if we treat this with the diazomethane and copper chloride, then what will happen? Then definitely it will generate the carbene, okay, and that carbene will make the addition reactions to the available double bond of this cycloheptatriene. So, what are the possibles? Now, actually there is possibility is that there it can react with two different type of double bonds are present here like this way. These two double bonds can react. So, what will be the product in this case? The product will be first this will make cyclopropane over here and another one that will give you the product over here. That means, the cyclopropane ring will form in this side. Okay. Now, let us say this is the two different cyclopropane containing 7 member ring has formed as a product. Now, if you see this particular substrates, this is a very good substrates for further forwarding to another sigmatropic rearrangement and give another product. This is called 3,3 sigmatropic rearrangement that will happen. So, if you see the numbering 1, 2, 3 and here 1, 2, 3. Now, if there is sigmatropic rearrangement happens, then actually this will form another product, and which is actually the degenerate with this particular product. So, the product will be okay. So, in this case if we counting it 1, 2, 3, 4, 5, 6, 7. So, the number of I mean the ring number is remain same, but we got the 3,3 sigmatropic rearranged product. This is called 3,3 sigmatropic rearrangement. Okay. Why? Because here if we see this at 3 position, here also at 3 positions, that new sigma bond is forming by the relocations of this pi and sigma bonds. That is overall this 3,3 sigmatropic rearrangement is happening here. That means, at the 3,3 place the new sigma bond is coming, and here at 1,1 place that new another older sigma bond that is getting break. So, overall what we are getting? We are getting the 3,3 sigmatropic rearranged product by this method, and this is very rapid, reversible, and because energetically both will be same. So, this is a very rapid, reversible, degenerate 3,3 sigmatropic rearrangement, and this 3,3 sigmatropic rearrangement, this is called, this is a very well known name reactions, this is called Cope rearrangement. Okay. So, this is another type of pericyclic reactions rather, or concerted reactions, that is giving the Cope rearrangement by 3,3 sigmatropic rearrangement. Okay. Next what we will see another similar type of substrates, that is the octatriene, cyclooctatriene if we take. Okay. So, this is the substrate. Now, again in similar conditions, if we generate the carbene, then in this case also there are two possibility. That means, here there are two different type of double bonds are present. So, what we will do under these conditions, if we now expose it under this carbene, then what will happen, again this will also form two type of cyclopropane containing ring. Okay. First case it will give this one, plus in another case this will give this product. Okay. Now, if we see this substrate, these two among these two substrate, this is also now ready for another 3,3 sigmatropic rearrangement. Let us see if we see the numbering. Okay. Now, this can nicely proceed through 3,3 sigmatropic rearrangement to give the product okay. Okay. So, in this case the number of, if we see that total number of carbons, that is over here total 8 1 9. So, if we start from here 1 2 3 4 5 6 7 1 1 1 2 3 4 5 6 7 8 9. So, overall number of carbons are same, but here what happened, here the ring has been converted from 3-member cyclopropane ring to another 4-member ring, and this gives the another 3,3 sigmatropic rearrangement. So, this is 3,3 sigmatropic rearrangement, or you can call it Cope rearrangement. Through these pericyclic reactions or the concerted reactions, this particular cyclopropane containing 8-member ring converted to its another 4-membered ring containing substrate or product, that is this one. Okay. So, in this case there are two possibilities, that two cyclopropane containing product will form, but after that one product which is easy to proceed through 3,3 sigmatropic rearrangement, that will give another product, and that is nothing but this 4-member fused product. Okay. Next we will see another type of derivative, that is called fulvene derivative. Okay. If the carbene will react with fulvene type of derivative, what will happen? So, this type of substrate, that is called fulvene type of derivative. Now, if we treat this one with dichlorocarbene, that will give this cyclopropane containing substrate, and if it will stay longer at minus 10 degree centigrade and with the presence of excess dichlorocarbene, then what will happen? Then actually this olefin, that will also react but at room temperature what will happen? At room temperature there this ring expansion will happen and overall this migration of this chlorine to this carbon, then followed by ring expansion will give this 6 membered benzene derivative. Okay. And here this one is the chlorine. Now, if it contains R equals to alkyl, then the liberation of this HCl will give the corresponding olefin derivative. Okay. Similarly, if R equals to phenyl, there is no possibility of these eliminations. So, in presence of sodium methoxide or other alkoxide, this will simply give the substituted product. Okay, can give OR double prime. Okay. Now, what will happen if these reactions will work with the alkyne? So, let us take the alkyne, okay, and if we treat this with the carbene, then obviously this triple bond that will react and generate the cyclopropene type of system like this. Okay. So, these are the cyclopropene. Okay. Now, if there is anion type of system, that means if the substrates contains double bond as well as triple bond, what will happen? Which one will faster react? Most of the cases in general it has been seen that if we take diazo ester as the carbene precursor, then if there is a indiene substrate, then first the double bond will react. That means, the alkene that is going to react first to give this product as major product, okay, and the further it will react to give this product as the trace amount. Okay. So, mostly these olefin that will react faster. In another example, if we take this cyclohexene containing indiene type of derivative, then in presence of dichlorocarbene, this will give that olefin will react with this dichlorocarbene to this to give this cyclopropane containing bicyclic compound. Here interesting to say that this derivative will further can lead to cyclopropanone type of derivative, but at this present this under this dichlorocarbene conditions, this indiene type of moiety can react with the specially with the olefin moiety. So, these are the all type of reactions, addition type of reactions that we have discussed with the carbene. Thank you very much.